Okay, so we're going to be working on task 4. This is the task that we've got. So we've got four-sided polygon, another four-sided polygon, and a sector and a segment. I've divided the four-sided polygons into two triangles, and I'm going to be working on each triangle. Now, the first triangle I will choose to work on is ECH. And the reason for that, because I've got I'm going to be working on CBH, and the reason for that, because I've got an angle and I've got two sides being given, so it's easy for me to calculate the third side, and then another angle, and then the third angle. So this time, I've actually worked it out, so we can just go through the working together, just to save time. So I've used the triangle CBH, this one here, and I've calculated the length side CH using the cosine rule. So I've got 11.35 square plus 7.21 square minus 2 times 7.21 times 11.35 times cosine 24.86. Because I'm using angles in degrees, so make sure that your calculator mode must be in degrees. So that's the answer, the length side for 5.86. So 5.68. Now, the angles BCG, I've used the sine rule for the angle first. So I've used sine for this angle here that I'm trying to calculate. So I've used the sine of this angle divided by 11.35, and then sine of this angle that's given divided by 5.868. And then what I got as an answer is 57.15. Now, if you look at the shape, you can tell that this angle here is more than 90 degrees. So that's why we've noticed straight away that we've got the ambiguous case of the sine rule. Now, in this case, then you will have two solutions. You either retry to calculate that angle using the cosine rule, as I've done here, or try to calculate this angle here using the sine rule. And those two answers will give you the right answer at the end. So I've used the cosine rule, so I've done exactly the same. I'm still calculating this angle here, but this time I use the cosine rule as I've got three sides given. So the answer is 122.5, and you can see that's more than 90, and it is, yes, because it's an obtuse angle. And then, so that's 122.5. So this angle here, calculating it now, is quite straightforward. 180 minus that and minus the other one, so this angle here is 32.64. Now I've got everything in this triangle, so I can calculate the area now. The area of this triangle is half times 11.35 times 7.21 times sine 24.86. You've noticed that I've used all the measurement that has been already given in the question to calculate the area. So the answer is 17.2. This method here, just to to help if you made any mistakes earlier, that doesn't affect the area of that triangle. Now we're going to move on to the next triangle. So the next triangle I've used is CEH, and you've noticed that I've marked it or labeled it on my paper. Then I'm calculating now the CHE, because the easiest one to calculate. I've got the whole thing, the angle H is the whole thing is 56.28. I already know this angle, so I'll just minus it, and the answer is 23.64. I always like to remark my answers that I've calculated back into the shape. It just gives me a hint where's my next step is going to be. Now I'm gonna calculate the angle CEH now, and I can use the sine rule or the cosine rule. So I've used the sine rule just for a variety, and you can see that I've used it all, and then the angle size give me 16.54. And now calculating this angle is quite straightforward, so I do 180 minus all the other two angles, and the answer is 139.82 degrees. Now, next step, calculating the area of this triangle here, and I've used half times 12.85 times 8 times sine 16.54, and the answer was 14.64. I'm highlighting those answers just to remember that I need to add them right at the end to find the total area of the shape. Now our next triangle is ACE, so this one here, ACE. Now in this case, some of you probably will use this triangle here to calculate the area of the triangle and then the area of the segment, or you can use the area of the sector, calculate the whole area of the sector. I've used the area and then the area of the segment just to show you how to do that in case that you can't do the whole sector all at once. Now, the area of ACE, so I've got this side is being given, this angle I can calculate now, so it's 58.99 minus 16.54, so I've got 69.45 degrees now. I've got two sides, so I can calculate this angle here now, and by using the cosine rule, so I've calculated and I got 41.66. Now if you know those two angles, then finding the third angle is quite straightforward. Just minus it from 180. Now calculating the area of the triangle, then you've got half times 8 times 8, and you've got sine 40 times sine 41.66, and this is the answer. Now calculating this angle here, probably not necessary because I haven't used it, but I've just calculated as I'm going through, so but it's not necessary. Now the next triangle I'm using, this one here, at the moment I can find this angle easily, angle at a point, so 360 minus all those three angles, and I've got 56.02, and I can find the length of AB, which is the same as the radius in here. So I've got the length in here 7.18, and now I calculate the area of this triangle here, and that's give me 23.92. Now I'm moving to calculating the area of the segment and the area of the sector. Because I'm now moving to calculate area of segment and area of sector, you must make sure that your calculator mode now moved to radius, and you are changing all the angles that you're going to be using into radius. So I've used the sigma first, so I've got this angle here, that's the center, because remember that's the information being given. C is the center of AE angle, so that means that's the radius and that's the center angle. So I've converted 41.66 into radius by multiplying by pi, divide by 180, and I've got this answer. Make sure my calculator mode in radius, and now I can apply the area of a segment rule, and I got 2.02 as an area of this segment here. Now the area of the sector, again, I've got, this is the radius, this is the 58.12, so that's the center area, center angle. Then I can convert it to radius by multiplying by pi, divide by 180. Got this. Make sure my calculator mode in radius. Now I can apply the area of a sector, and I've got 26.03 as an area. Now calculating the total area is easy, just adding everything up that I've highlighted in blues. I've got 1, 2, 3 sections, 4, 5, 6 different shapes, and I've got 1, 2, 3, 4, 5, 6 different shapes. And I've added all the areas together and given me 104.89 as the area of the total shape. Now the perimeter. The perimeter, as we talked about before, is the outside length. So I've got the length of this side already. I've got the length of this side. I've already know the length of this side, as this is the radius. So this one will be 7.18 as well. The only two things that I need to calculate now is the arc length. And because already our calculator mode is already in radius because of the steps now, so we can just apply the arc length formula. So the arc of GB, just this angle here in radius times the radius times the radius of the angle, and I've got 7.12 25, and then this arc here I've got 5.85, and I just added this side plus that plus the arc length plus this side plus this arc length. Parameter only the outside, so none of those sides involved, and the parameter is 44.47. Thank you for listening.